All right, so we did a whole bunch of calculations. Great. All right, so now let's figure out a whole bunch of answers to questions. So let's analyze what we just found. Describe the shape of this distribution. Explain your choice. Well, there's a couple ways to figure it out, but the easiest one for us is the mean to median comparison that we saw in section 3.1, and then we also briefly saw it again in section 3.4. If your mean is significantly greater than your median, it's skewed right, which this totally is, right? That mean is much larger than that median. And that's what I'll type up for my reasoning. The mean is much larger than the median. How about this? Significantly larger. That's the word we usually use because much is, it's no different really, but you're just trying to say that there's a significant relationship here. I mean, being a little bit larger, that'd be no big deal. I mean, if it was 18.3 and 18.6, that's probably nothing. But 18.3 to 29.6, when you're talking about billions of dollars, that's a big deal. That's quite a bit larger. So you're making a little bit of a judgment call there. You could also look at a histogram. You could also look at the differences between the median in Q3 and the median in Q1, or the median and the max, the median and the min, that kind of thing. So you can make an argument from the 5-number summary as well. All right, so then what measure of central tendency should be used when reporting about this data set? Well, let me go back to the set table in section 3.4 real quick. In 3.4, we ran into this table, and see there it is, skewed right is the mean is greater than the median. When that happens and you're skewed, your better measure of center would be the median because it resists that skewing. Remember, we learned about that in section 3.1. As a matter of fact, the first version of this table appears in section 3.1. This is just the more robust version here in section 3.4. And then this is the picture, right? So you could do a histogram or a dot plot or something like that, or even a box and whisker plot. So then the IQR is the better measure of spread, right? So the IQR, because it resists that outliers, resists that skewing. So looking back at our question, what measure of central tendency should be used when reporting about this data set? So the measure of center that should be used is the median. And for the record, the measure of spread, matter of fact, I'm going to add that in. The measure of central tendency and spread should be used when reporting about this data set. And the answer is the median and the IQR because it's skewed right. There we go. So the better measure of center is median, better measure of spread is the IQR, and that's because the data set is skewed right, and these two measures are resistant to that skewing, and also to outliers, right? Which, if there are any, which is very likely in a skewed right data set like this, then it would those two values would be resistant to those outliers. There we have it. So better measure of center, better measure of spread. Okay, now we're given a mode of 10.3, but we don't know how many countries have that value. So remember what the 10.3 stands for. So the mode equals 10.3 means that more than one country would have 10.3 as their export value. Okay, so the mode being 10.3 means that the U.S. exports $10.3 billion to more than one country worth of goods, I should say. To more than one country. The problem is that we don't know how many countries are at that export level. If there are 7 out of our 10 countries at that level, that would be very revealing about our data set, but that information was not given, so we don't really know how much about how common that value is. And that's problematic, right? So we know it's the mode, but it could be as low as 2, or it could be as high as, 11. We just, well, not that high, but you get the gist. It could be 3 or 4 or 5 countries. And that's a very different world if you have a lot of them that are at 10.3 versus a few of them. And we just don't know. All right, next. There are 2 variances given. Oh, we already went over this, which was more appropriate for our data set. So this is a little bit out of order because we already figured this out, but that's all right. Let me type it up real quick. There, I just typed up what we already said, which is that the variance is s squared. The unadjusted variance is sigma squared. So it gave us both of them in the output, but we have to be smart enough to know that it's this s squared that we want because this was a sample. Your calculator does the same thing, by the way. Your calculator will give you s and sigma, and you have to kind of look at your data set and figure out if this was a sample, I'll use the s one. If it was a population, which will happen to you sometimes, then use the sigma one. So you use whichever one is more appropriate. All right, now the mean and the standard deviation. Well, we found the mean given to us, which was 29.64, and then the standard deviation is 38.189. So if we use our usual give and take language, the mean plus or minus the standard deviation, we expect that the U.S. exports about $29.637 billion worth of goods to any country, give or take, or any random country. Give or take about 38.189 billion. Now there's a problem with this. If you think about the give or take for just a second, that gives you a range of, well, let's find it. If I take 29.637 and I add on 38.189, I get that value of 67.826. If I hit second entry, I can get the same numbers back. I'm just going to use my arrow to get in here and make that a minus sign. And I get negative 8.552, which should be setting off little alarm bells in your head because we said that this data set was ratio. Ratio can never be negative, right? So if this value, if this range gives you a sign or gives you a value that's impossible, right? Impossible. Because the data are at a ratio level of measurement. If that's the case, then that's a sign that the data set was skewed right. It's another way of noting that the data set was skewed right. It only works for ratio data, right? Because ratio data cannot have negatives, right? Which can never be less than 0, can never be negative. Here, let me put that way. Can never be negative. Right. If that happens, that's a sign that your data set is skewed right, which it did in this case. So it doesn't mean that you don't write it. It doesn't mean that you don't write this interpretation. You'd say most countries are between these two values right here. There. In other words, the U.S. exports between negative 8.552, which is impossible, and $67.826 billion worth of goods to most countries, right? Let me just put impossible next to that negative one because we all know that that's not possible. And that's a sign that the data set was skewed negative, or skewed right, excuse me. Not skewed negative, skewed positive, as a matter of fact. There, and I just wrote that up. This was a sign that the data set was skewed right. And it'll only work for ratio data, obviously. So it has to be that your data set is ratio, because if it was interval, then you can have negatives all day long. So the fact that this couldn't be negative in real life terms, you can't export negative $8.552 billion worth of goods to a country. You can have a trade balance that's negative, but not exporting that much. All right, now how can you tell from the given information that there must be outliers in the data set? Well, the max is kind of a sign. So when you look at your fences right here, your upper fence is 51.05 billion and your lower fence is negative, right? Well, the negative one we can ignore because we're never going to have a country that we export less than negative 14.15 billion. We're never going to have a country that low anyway. The lowest we could export to is 0. So the upper fence is where it's going to happen. And you can see that the max is above that upper fence. So the max value is 160.8, and that's above that upper fence. So you know that at least the maximum is there. All right, so let me type that up. Okay, so the upper fence was 51.05 billion. Since the max is 160.8 billion is larger than that upper fence, we know that the max is an outlier. Now, keep in mind, there could be other outliers as well, but the max is the only one that we have evidence for within the statistics output given, right? So that's the only one we know about for sure. And there was no outlier possible on the low side because we could never have exports being in the negatives. So I'll just make a note of that. So it was impossible to have a lower outlier because the min, which was $4.8 billion, is not below the lower fence. As a matter of fact, it was impossible to be below the lower fence because the lower fence was negative, which is never going to work. I mean, it's fine, it's the lower fence, but we're never going to have a value that's below 0, let alone being negative. All right, last but not least, the U.S. exported $97.5 billion worth of goods last year to Mexico. So that's ones, tens, hundreds, right? There's the thousands, that's the 100,000s, that's the millions, that's the billions. So it's $97,500,000,000 worth of goods last year to Mexico. Find the z-score. Little known fact that the Mexico is, I believe, our #2 trading partner after Canada. Canada is the max, in case you were, just curious about American trade. So Canada is really large at the max value of 160, and Mexico is pretty close behind, I mean, relatively speaking, at 97.5 billion. So the first thing I'm going to do is I'm going to change this to billion dollars, right? So since our unit was billion dollars, we've got to convert it. So I moved the decimal place over to match the rest of our data. And then I remember the lovely z-score formula that we learned in chapter 3 or section 3.2. Oh no, 3.4, sorry. 3.4 measures of position. So it's x minus x bar divided by s. Now I'm using the x bar in the s version because of course this was a sample. If it was for the what do you call it? The population, if they gave us population values, then I'd use population values. All right, so I'm going to divide this by, I used the square root, but I didn't need to there. So I'm going to go remind myself what the heck our standard deviation was, because we already calculated it. Standard deviation was 38.189, so I'm going to divide by that. So let me just prove this to you. Parentheses 97.5 minus 29.64. And the #1 mistake students make on this problem is they will not use parentheses, and that's a bad idea. Use your parentheses. They are your friends. So either use parentheses or use the alpha F1 business. Pick #1, and you can type it like this. And I'm using my arrows to kind of work my way around here. There we go. So you can see it's 1.77695, right? So I could put 695 right there. Or if you want to round it to 3 decimal places, that'd be 1.777, roughly. Because the 5 rounds the 69 up to 70, so 1.7770. All right, now what does that mean? Oops, scrolling back down. What does that mean for the context of the situation? Well, the U.S. exports a lot to Mexico, but it's not unusually high because the z-score is not more than 2. Remember, that is the definition for unusual for us. So we export a lot to Mexico. As a matter of fact, Mexico is #2 in our trading partners. But it's not quite at an unusually high level. We're getting close because it's really high, but it's not at 2. All right, there we go. We're all done with that problem. And I hope that was very useful for reviewing pretty much every concept that we learned in chapter 3.